Thank you for joining us. My name is Clint Olson, and I am the sales engineer for Stan Weaver's Jacksonville office, and I'll be hosting this webinar today. Stan Weaver and Company is a leading manufacturer's rep in the HVAC industry. We now have 5 offices serving most of the state of Florida, located in Jacksonville, Orlando, Tampa, Miami, and West Palm Beach. Stan Weaver and Company has an unwavering commitment to excellence, and we position ourselves with only premier HVAC manufacturing companies. After this meeting, in your spare time, please check out our new website at stanweaver.com. There's now a great searchable line card under the Manufacturer tab on our website. When you're in search of a product for your project design, always start with stanweaver.com. This is the 4th of a 10-piece webinar series Stan Weaver will be hosting throughout this year. We appreciate everybody taking the time out of your busy mornings to learn and educate yourselves on a great industry manufacturer product offering. A few quick housekeeping items before we begin. First, this will be recorded. Second, this is the 4th of a 10 total webinars that we'll be hosting this year. If you've made it to our previous webinars and now this event, you're one step closer to winning a chance to win an iPad. These presentations will be no more than 30 minutes in length, and then we'll follow with a short Q&A session for a brief period afterwards. We've muted all attendees for the length of this meeting, and we'll be utilizing the Q&A function within Zoom located on your screen. If you have any questions throughout the presentation, please make sure to submit them in the Q&A section, not the chat section, and we'll get to those at the end of the presentation. Lastly, there's a survey at the end of the event. Please take the time to complete and submit this survey for us. We'll review all submissions, and we will use these comments to improve this series for us and all attendees for future webinars. Now, with no further ado, I'd like to present our speaker and topic for the day. Mr. Jeff Gezzi has been a regional vice president for GPS Air for the last 3 years. In that time, he's focused on improving IAQ for clients in many different industries, including education, healthcare, manufacturing, and office environments. Prior to joining GPS, Jeff worked at Carrier Corporation for 14 years. Leveraging soft ionization to improve indoor air quality, today we'll cover the basic principles of ionization, odor mitigation, and coil cleaning. And now, Jeff, the floor is yours.
Thank you very much, Clint. So thanks for everyone for joining me. Stan Weaver, Clint, Eric, thanks for having me today. Our learning objectives for the day, we'll start with the benefits of ionization, where you can use ionization to improve a facility. We'll differentiate between different types of ionization, soft ionization versus hard ionization. Then get into some details on how ionization works to clean the air, what physically happens, and then we'll get into a couple of specific applications. One, coil cleaning. It's a great substitute for UV, much easier than mechanically cleaning the coil, and outdoor odor mitigations. These are 2 very, very popular applications for us. First of all, where would ionization benefit you? We normally look at 3 different buckets. We look at human health, where we clean the indoor air through particle management and pathogen reduction. As many of you might know, ASHRAE has come up with a new procedure, a new standard 241, which ionization is a part of. So it's a good validation by ASHRAE as to the benefits of ionization for human health. Second bucket is energy and operational savings. We're going to talk about clean coils today and what that can do to save money by slowing down your fan speed if you got better heat transfer through the coil by having a clean coil. Another popular application in Florida we're not going to talk about today is the IAQP product or IAQP process. I think as we look forward, IAQP is going to be a more prevalent way to calculate outdoor air requirements. There's the VRP method, the ventilation rate procedure method, which works on the idea of dilution. IQP looks at cleaning the air in the space itself from a carbon footprint standpoint, from an energy usage standpoint, IAQP is much more effective. Then odor management, really odors are going to be small particles. So as we talk about agglomeration and how ionization works to make small particles bigger, to make your air cleaner, help your filters become more effective, it's also going to take care of odors. We're going to talk about one specific odor application, and that's outdoor odors coming inside. Just to make sure we're all on the same page, what is an ion? An ion's nothing but a positively or negatively charged molecule or atom, and they occur regularly in nature. Anytime you have water crashing, you'll see a higher ion level. We had one guy from the office go on the Lady of the Mist cruise by Niagara Falls, and he read 1.5 million ions per cubic centimeter. So just to give you a feel for what you'll see in nature, these ions are constantly cleaning the air. In the GPS technology, for the most part, all but one of our products fit into your HVAC system. The idea of agglomeration is we're going to bring ions into the space. It's going to be an active air cleaning technology. So in the ductwork, we'll place our units. The units will put ions through the ductwork, come out the diffuser, and clean the air in the breathing space. I think this is very important. There's other technologies such as filters, which are passive. In order for those filters to clean the air, we need to get what we want to take out of the air to the filter. What ionization is going to do by working through the ductwork, through the diffuser, is it's going to clean the air that we breathe. So proactively taking any respiratory irritants out of the space. Now, there are a couple of different types of ionization. At GPS, we have a soft ionization product. We'll put a static charge onto particles. Our units have two emitters. One side works like an electron gun, and it's going to shoot electrons at particles that are naturally in the air. Those particles, as they pick up an extra electron, will be negatively charged. On the other side, it works like a suction pump, and it's going to pull an electron away. Those particles will be positively charged. So this static charge that we put on particles to make them ions do not create any air chemistry. Sometimes you'll see people concerned with air chemistry. There are products in the market that would be a hard ionization. You can see to the right here, which uses a higher energy field and will actually break apart molecules. Hard ionization, the most extreme example would be lightning, but there are other products you'll hear referred to as corona discharge, dielectric barrier type technologies, Crookes tubes, which will cause air chemistry. The problem you can have with that is once you cause a chemical reaction or air chemistry reaction, you really can't control it. So here I have an example of what could happen with O2 oxygen. If we were to break O2 into O, two O molecules, and then O were to combine back with O2, you would get O3. O3 is ozone, which is very good in the upper atmosphere. It protects the earth from the sun's UV rays. In the lower atmosphere, it causes respiratory issues. It's very, very reactive and also corrosive. If you look at ASHRAE, CDC, really any of the HVAC or air quality groups, they'll all say, if you're looking at air cleaning devices, make sure that they're ozone free. There's a couple of ways you can find that. UL has a standard 2998, UL 2998, which is a no ozone creation standard. It's actually less than 5 parts per billion, which is less than the detectable limit. You can find what products are ozone free by going on to the UL Spot website or the Intertech website. You put in the manufacturer's name, you'll see what products are ozone free. All of GPS's products are ozone free. We won't come to the market with a product that is not. So a very important thing is you're looking at different technologies. How ionization works from a particle standpoint. Really, ionization, its benefit is going to be in your small particle range. Here you can see a relative size of different particles. When you start looking at 2.5 microns down to 1 micron. Those are the particles of the concern. Those are the particles where ionization is going to have its greatest impact on the space. And you can see here as we get to 1 micron and less, bacteria, wildfire, smoke, viruses, all of that, all your respiratory irritants live in that 1 micron or less size. That is important because most of the particles that are in the air, if you see here, 98.5% of the particles by count in the air are going to be these small 1 micron and less particles. It's only 3% by weight. So if you have an interest in measuring your indoor air quality, please be sure to look at particle counts, because it's the particle counts that really make a difference. Larger particles, as you can see on the right, your body has a normal defense mechanism against. Those larger particles will get caught up in your nasal passage, your upper respiratory area. It's the PM1, PM stands for particulate matter, 1 micron and less. That's what gets deep into your lungs. That's what causes respiratory issues. That's what causes you to get sick. Added on top of that, if we look at the ASHRAE handbook and the settling times for different particles, you can see here bacteria, tobacco smoke, and viruses. Those particles don't settle very quickly. Viruses up to 13 days and bacteria between 21 minutes and 475 minutes. What that tells you is those small particles, 1 micron and less, they don't move, excuse me, they don't move with the airflow. There's not enough mass for the airflow to take those particles over to the filter and allow the filter to capture them. So I think we saw this during COVID, right? We never saw examples of COVID making its way into the ductwork. We saw that it stayed suspended in the air, and the risk of somebody being sick was for people coming into the room after the sick person may have left. That's the same with influenza, same with other viruses that we have today. So small particles, because they have no weight, they don't move with the bulk air. The physics of it all also means that it's the area where people are most affected. Now, this is a popular chart. This is a filter industry chart. It shows MERV. It shows the different MERV levels in particulate capture effectiveness on the y-axis and particle diameter on the x-axis. Again, if you were to Google MERV effectiveness, this is the curve that would come up, and it shows that as we're in that small particle size, that 0.1 micron to 1 micron, no matter what type filter you use, the effectiveness drops off. So MERV 8, probably the most popular filter. In the area of concern, you'll see it captures about 10% of those particles. I think a big push lately has been to move up in your MERV rating to MERV 13. And you can see there's a huge benefit to it. That's the green dotted line. It'll get you up to 40% of the particles captured. When we look at MERV ratings, a lot of times you'll just see one rating for a MERV curve. And that rating, that capture rate, is on the right-hand side of this curve, not at the weak point of this 0.1 to 1 micron. All of this sets up for a pretty good test of ionization. This idea that we're going to bring these charged particles in the space, agglomerate onto the small particles, snowball onto those small particles to make them bigger, should move the particles down the right-hand x-axis to the point where your filter is much more effective and efficient. So we run a third-party test, 10 by 10 by 10 chamber using Blue Haven Labs. We're going to run 6 air changes an hour, 1 air change every 10 minutes, adding PM1 calibrated cigarette smoke at the beginning. And we're going to see how quickly a MERV 10 filter is able to take those particles out of the air versus a MERV 10 filter plus ionization. So 6 air changes an hour, starting with 1 micron and less particles. After 1 air change, 10 minutes, you see that about maybe 5%, 8% of the particles of concern are taken out of the air. We move forward to 40 minutes or 4 air changes. We're above 20, maybe 30% of those particles taken out. The shape of the line looks very similar to the filter industry curve. Continue to move forward at 9 air changes. You see about 40 to 50% of those particles of concern are taken out. And after 6 hours, 360 minutes, probably about 90% of the particles taken out of the air. Probably all of this falls into what we would expect based upon the filter industry data that we saw. When we add ionization, 1 air change, 60% of the particles are taken out. 4 air changes, we stop the test because there's no particles left to be taken out of the air. So this is really the greatest example of how ionization works to make those small particles bigger, help those small particles move with the bulk air, and allow your filters to be more effective. A lot of times people will talk about how ionization plus MERV 8 filters will give you performance similar to MERV 13. When they say that, they're talking about these small particles and the benefit to ionization at particles 1 micron and less. Another way to look at this, a lot of times we'll talk about air changes. If we look at the equivalent air changes, 1 air change with ionization gives the same performance, a very, very similar performance to 24 air changes with MERV 10 by itself. So again, I think this is a powerful example of how agglomeration helps benefit a space by taking particles out. Pathogens. Now, pathogens are going to be small particles. Aerosol scientists will talk about viruses catching a ride on particles between 0.3 and 1 micron. There's a secondary benefit to ionization, and that's the receptor. So all viruses, all respiratory viruses are shelled viruses, and they have receptors that come off of the shell of the virus. And the way you get sick is you breathe in the shelled virus. The receptors connect up with your lung tissue, replicate, and that's how you get sick. With ionization, because those receptors are positively charged, the negative ions are going to neutralize the surface proteins so that when you breathe them in, they're unable to replicate on your lungs, unable to get you sick. You can see here some of the viruses and bacteria that we at GPS test against, both in the air and on the surface. The results you can find on our website, gpsair.com. There will show ion densities and net rate of reduction. Into a couple of the specific applications, one that's been quite popular lately is coil cleaning. And this is our product on the right we call the iMod. And the bar you see there, the blue bar you see, would go against the air intake of a coil, an air handling coil. And it will affect the membranes of the biofilms to stop them from being able to attach onto the coil itself. So we have a great case study with Novant Healthcare Facility in North Carolina, where they had an issue with an older facility, 28,000 CFM air handler. It was a 16-row air handler. Was running 3.5 inches of static pressure. The fan had been running at 100% for 2 years, and they got to the point where they couldn't make supply air temperature anymore. So with them, it looked like they were going to need to spend about $70,000 to change out the coil because it was impacted, but they gave us a shot to put our iMod on to see what we could do to get rid of those biofilms to improve the pressure drop across the coil. So here you see just the test setup. We used a couple of iMod bars going the width of the coil itself. And then some background on the fact that for 2 years, they had been running at 100%. Probably if they had more fan, would have run above 100%. So we put the iMod on. You can see here in mid-September. And within a month, we were able to knock down those biofilms to the point where they were running at a lower fan temperature. The pressure drop across the coil had dropped off, and they were able to make the supply air temperature. For the customer in this case, they saved $70,000 that it would have cost them to change out the coil. Our product installed really depends on where you are. It's going to be $15,000 to $20,000. So an immediate payback if the benefit was eliminating a $70,000 cost. But even if you just look at the reduced fan speed, we would have seen a $9,000 a year savings in energy. Just the fan speed of the air handler. Now, if this air handler was on a loop, or if the air handlers on the loop all had this issue, and you're running your chiller at a higher rate in order to overcome the ineffectiveness of the coil, the lack of heat transfer across the coil, the savings would be even greater than what we see here. So for us, a very strong business case to show the benefits of the iMod on a coil. And really, as we look at it versus other applications you can use, certainly you can manually clean a coil. With labor being tight in a lot of markets, that can be tough to get to. You can also use UV. I think when we look at that technology versus ionization, a benefit to ionization in our iMod product is there's no replacement parts. There's limited maintenance, where all we ask is that you clean off the emitters every time you change the filters with isopropylene alcohol. The product itself only takes up 15 watts, so it's about a UV bulb, or not a UV bulb, an LED bulb. Doesn't have any ozone. There's no byproducts that are created. You really don't have any EHS concerns of radiation. And even where you guys are, we're on a coastal application. You don't have to worry about any interaction between the iMod and any coil cleaning or any coil coatings you might need for corrosion resistance. Along with this, just to show our how dedicated we are and our confidence in this product, we do have a 6-month guarantee. So if you decide you want to install the iMod and use it after 6 months, if you're not satisfied and that satisfaction is just based on you, there's no monitoring, no measurement associated with it, we'll give you the money back for the product itself. Odor management, the same product is really good for odor management. Healthcare, again, is a most popular example I can think of. Airports is another one, where you have a helicopter pad or jet exhaust, and you're worried about that exhaust coming through the air intake in an air handler. We can put the iMod on the front side of the coil, and we can eliminate that odor from getting into the space. So here you see a couple of healthcare groups. I think Boston Medical has used it also. There was a diesel generator issue similar to what we see here at Monument. In the Methodist application, they had been using carbon, and the carbon cost them about $30,000 a year. They switched over to the iMod, were able to remove the carbon, not have that cost going forward. So again, a secondary application. And that's the end of my presentation for today. Anybody that's interested, certainly Stan Weaver experts at GPS. We also love to have customers come up, see our facility. We're based right outside of the airport. It can be a great tour to understand ionization. And that's all I have.
Awesome job, Jeff. Thank you so much. We really appreciate it. Currently, we don't have any questions in the Q&A section, so maybe we'll give it here just another second before we log off, but that's it. All right, looks like that's it for the day. If anybody has any questions, comments, or concerns, please reach out to Stan Weaver. Thank you again, Jeff. Really appreciate your time.
Be well.